start fourth topic, that is thermodynamics, and this is our lecture number 1. See here, thermodynamics. What is meant by thermodynamics? It is a branch of physics which studies the conversion of work into heat and vice versa. Work to heat and vice versa. Here we study how the work is converted into heat or heat is converted into work or any form of energy. Work means any form of energy, how that energy is converted into heat and vice versa. It studies or it deals with the concepts of heat and temperature, and the interconversion of heat and other forms of energy. This is our introduction. Now we will see what is meant by thermal equilibrium. Thermal equilibrium. What is meant by thermal equilibrium? Here we consider generally temperature or heat always flows from higher temperature to lower temperature. This is the natural tendency. Temperature always flows from higher temperature to lower temperature, and this transfer continues till the heat containing both the substances is same. Suppose you can say this is the substance which is at higher temperature, this is the substance which is at lower temperature. Then heat flows from this higher temperature to lower temperature till both attains the same temperature. And this condition where both attains the same temperature, it is called as thermal equilibrium. Now we consider next Zeroth Law. Zeroth Law of thermodynamics. Zeroth Law of thermodynamics. Here we consider first a statement of this law. Simple statement. If two systems are in thermal equilibrium with a third system, they are also in thermal equilibrium with each other. Suppose you consider diagrammatically. Suppose this is system A, this is system B, this is system C. Now here, suppose A and C are in thermal equilibrium. Now we consider next condition. Suppose this is system A, this is system B, and this is system C. Here we consider, suppose A and B are in thermal equilibrium. Then according to this Zeroth Law of thermodynamics, suppose you consider again here A, here system B, here system C. Then here we consider these two systems B and C are also in the thermal equilibrium. Here see, again I will explain. So here we consider A and C are in thermal equilibrium, A and B in thermal equilibrium, then A with C, A with B, which implies B is also with C in thermal equilibrium. And we consider here the science of measuring temperature is called thermometry. Thermometry. What is meant by thermometry? The science of measuring temperature, means it is a thermometry. Now we consider next article, heat, internal energy and work. Heat, internal energy and work. First we will see what is meant by internal energy. Internal energy. What is meant by internal energy? Internal energy is energy associated with the random motion of molecules of a system. Energy associated with random motion of molecules of a system, and this energy is always denoted by U. Here we consider thermodynamic system and thermodynamic process. Now thermodynamic systems, thermodynamic system and thermodynamic process. A thermodynamic system is collection of group of objects that can form a unit which may have ability to exchange energy with surrounding. Group of objects which exchanges heat with surroundings. Here this group of objects is called as thermodynamic system, and anything that is not a part of system, is called surrounding, or it is also called as environment. For example, we consider suppose this is a vessel in which suppose water is kept. This is the vessel in which water is kept. Then this water vessel is boundary. This vessel is a boundary, and this water, and this is the system, and anything outside the system we call it as a surrounding. This is about thermodynamic system and surrounding. Now we consider suppose this is a type of system. Here we consider suppose this is the system, then this is boundary. Already I have told in case of water in a vessel, and we consider anything outside the system, it is surrounding or environment. This is about thermodynamic system and thermodynamic. We consider system and surrounding. Thermodynamic systems are classified on the basis of transfer of heat and matter to the surrounding, and based on this they are classified as open system, then closed system, and third one we consider isolated system. What is meant by open system? Suppose we consider this is the matter, directly this is the matter. Okay, now we consider here, suppose this is the matter, and we consider here another one, suppose this is the matter. Now here this matter is open. Now it exchanges heat and also matter to the surrounding, so we call it as a open system. Now here we consider, suppose here we close this system. Here by blue pen. Then it exchanges only heat with the surrounding, not matter. So we call it as a closed system. And here we consider, this is third one. Here we consider on all sides there is a boundary. No heat or no matter is given to the surrounding. Heat and matter not given here, not given. And this system we call it as a closed system. For example, we consider here, suppose water is boiling in open kettle. Suppose this is the kettle in which water is boiling. See here, suppose we give here burner. Then what happens? Water boils. That means heat is given to the surrounding, and also steam. See here, heat, and we consider steam means matter. Therefore, we call it as a open system. Now, suppose we consider water is boiling in a boiler. Suppose we consider this boiler closed. Here, suppose water is boiling. Then what happens? Heat is given to the surrounding, but not matter. And we consider this. We consider, suppose water is boiling, but this system is completely sealed. This system is completely sealed. For example, we consider, suppose thermos flask. Here what happens? No heat nor that is matter is given to the surrounding, and this is called as closed system. Now here water contained in a vessel, we consider the heat is given to it and it starts boiling and steam is produced. Here pressure, volume and temperature of water inside it changes, and also state of the matter. This is all about three types of thermodynamic system and thermodynamic process: open system, closed system, and we consider here isolated system. Here isolated, not isolated system. Now we can start next article. Heat. Here we consider, suppose any system. Suppose this is a system whose temperature is Ts, and we consider this is environment whose temperature is T. Now here suppose there is exchange of temperature between system and surrounding till Ts and Te becomes equal, and this is called as thermal equilibrium. If environment is at large, then heat flows from environment to system. Also, whenever environment is large, then Te cannot be correctly measured. Then till there is an exchange of both, that is temperature between environment and surrounding, till the temperature becomes equal. Now here we consider, suppose we consider first case. Suppose we consider figure A. Here suppose we consider that is a Ts less than T. Ts less than T. Then internal energy Q flows from environment to system, and Q is positive. Q is positive. Then internal energy Q flows from the system to, here we consider this next case, that is if Ts greater than Te, then internal energy Q flows from system to surrounding, and Q is negative. And if Ts is equal to T, then Q is equal to 0. That means heat transfer is 0. Here we consider this is all about, and here no transfer of heat or energy. This is all about heat. Thank you.